So this is an answer to a question I received by email, but I thought it might be beneficial for everyone. So the question was, how do we graph trajectories? And I'm going to use an online grapher for this. That's not necessary, but I think it does make it easier. So in order to graph trajectories, we have to start with the solution to a differential equation, a system of differential equations. I'm taking a 2x2 system right here, so assume A is a 2x2 matrix, and then I just picked a nice general solution where we have a couple of different things going on. We've got a 0 and a 1, we've got a 1 and a 1 here, this one's negative, that one's positive. So in order to graph the trajectory, we really want to write this as a parametric set of parametric equations. So we take, and instead of writing it in our fundamental set of solutions form here, our regular general solution form, we combine these two. So I'm going to call them x and y because that's how we're going to graph them. Normally we would call them x1 and x2, but when we're going to graph parametrically, we're assuming x1 and x2 have that typical xy relationship. So little x will be equal to c1 e to the negative t, little y will be equal to c1 e to the negative t plus c2 e to the 2t. Don't get hung up about the particular numbers here. Remember, I didn't actually solve the differential equation. I just said that looked like the solution to some differential equation and it looked nice enough to play with. So I haven't solved anything here. All I've done is rewrite this solution in parametric form. So in parametric form, then the next step to graphing trajectories is to pick specific values for your constants. The one that I've done in the notes a lot, these two here, is let one of your constants be 0, let the other one be 1, let the other constant be 0, let the other one be 1. So if we let c1 be 0, then that wipes out both of these terms, so we get x is always 0 and y is always c2 e to the 2t, and that's right here. If we let c2 be 0 and c1 be 1, then that wipes out the e to the 2t, and we actually get x and y are equal. I wrote that down there, but it's just a little off the bottom of the page. There we go. So we actually get x equals y. That one would be really easy to graph, but I'm still going to show you how to use parametric equation grapher to do so. And then this one is a case that's a little more complicated. And we could have picked one of these to be a negative one. It really wouldn't have changed anything. I mean, it would change what the graph looks like, but the process is the same. So all I did is put 1 and 1 in for my constants here, rewrote x and y, and then I'd like to look and see if I can notice anything going on here. And realistically, this doesn't tell me much except that it's after t is a sufficiently high value, this is always going to be greater than x. Actually, I guess it's always going to be greater than x. So, so then let me share my screen here. I've gone ahead and graphed them, and I used Desmos's online app, but you can use any parametric grapher you can find. Where did I put that? There it is. All right, so this is the first one. This is x equals, and you can look over here in the ordered pair, x equals 0, y equals e to the 2t. Desmos does require a finite range for t. I tried plugging in infinity and it didn't like it, but I found that 10,000 was close enough to infinity for all practical graphing purposes here. So this is essentially t goes from negative infinity to infinity. One thing this Desmos app won't do is show you direction. So we kind of have to look at that ourselves. Notice that as t increases, y increases. So the arrows here, I don't think I can draw arrows on this. Maybe. I don't normally use this app. Anyway, the arrows here are going to point toward infinity on the positive y-axis. Then this is the second solution. Remember, I said it was x equals y. It is x equals y, but we're only going to get either the positive or the negative side of it. In this case, the positive side of it, because remember, x and y were always positive. They were always e to the negative t. And as you can see, this won't actually be all the way at 0 if I zoomed in, but for all practical purposes, the 10,000 I picked here is close enough. Now, the other thing you need to remember is which way are the arrows pointing. And on this one, as t goes to infinity, x and y will both be going to 0. So we point the zeros down and to the left. Point the arrows, not the zeros. Point the arrows down and to the left. And then the third one looks a little different. And I'm going to try to zoom out on it a little bit here. So you can kind of get a feel for what it's doing. It actually is coming in when t is very small. Then remember, we're up in the top right corner. I really wish I could highlight with this tool. There, maybe you just spotted where I right-clicked, hopefully. So up there, that's for very small t, and when t is very small, then we're very close to y equals x, and as t increases, we move down the curve this way, and then eventually the e to the 2t starts to pick up. So when our e to the negative t is very small, when t is close to 10,000, say, then this starts shooting up that way. And so that's the direction that our arrows travel, or point in this particular trajectory. And that's all a trajectory is it's a graph of the parametric system for a specific choice of constants. And if you're just asked to graph a couple, the 0, 1 cases are pretty easy typically. Occasionally, putting something like a 1, 1 or a negative 1, 1 in will give you something interesting as well. I hope that helps.